What's up, ASVAB party people? It's Anderson, your ASVAB coach, and welcome to part 2 of the 5-part mini arithmetic reasoning practice test series. So, in this video, I'll be going over step-by-step solutions to 5 examples with test-taking strategies to help you tackle these types of questions on the ASVAB. And you can pause the video and try the example problem out yourself if you'd like, or just follow along and see all the little tricks that you can apply to make your life easier. And as always, don't forget, you can get a full free ASVAB practice test with video solutions and free registration to my weekly classes on Zoom by clicking the link in the description of this video. So make sure to do that now before you do anything else, because why not take advantage of someone who wants to help you for free? So with that said, let's get right to the math action, my party people, and let's raise your ASVAB score. Let's go. All right, so example number 1 here. We have a unit conversion word problem, as you can see right there at the top right corner. And we really just want to treat this the same as we do any word problem. Always start with the question, what do you want? Then go through the information to make sense of the story so you can build a connection and solve this problem. So here we go. Part 1, read the question. It says, for how long was Stephanie working on the task? Sounds good. So it looks like we want a time amount. We want to know how long Stephanie was working on this. Great, cool. So what we want, time on task, right over here. And we'll say blank hours, blank minutes. And I'm only writing hours and minutes because if you look at your answer choices, they all say hours and minutes. So cool, sounds good. Now, typically, when you want to know how long somebody was working for, you might have a starting time and an ending time. Or you might have information about pieces of the task, like it took them this long to do this part, this long to do this part. So we don't know if we have to add or subtract yet, but what I notice is that I have the power to read the information and figure that out. So again, take it nice and slow as you get started, and then move faster and faster as you're ready to go. So here, Stephanie began a task at 9:27 a.m. and ended at 1:17 p.m. For how long was she working? Okay, cool. So with that said, we have the start time and end time. If we want to know the time on task, subtract. We got to subtract the time. So we need to know essentially the connection here is how long is it from 9:27 a.m. to 1:17 p.m. That's essentially what we want to know, the time difference between these two times. So let's go ahead and just do this a really quick way. It's not going to be by subtracting. It's actually going to be by starting from the beginning time and adding up until you get to the end time. Because watch this. To go from 9 a.m. to 1 p.m., how many hours is that? Well, if you just count from 9 a.m., 10 a.m., 11, 12, then 1 p.m., 4 hours right there. So if we add 4 hours, we end up at 1:27 p.m. But that's not exactly what we need, because if you take a look, hey, we're at 1:27, but we need to be at 1:17. So let's take away 10 minutes. Take away 10 minutes, you're right there. You're really close. We ended up adding hours to get to the right hour. Now we're gonna add or subtract minutes to get to the right minute. You see where I'm going with this? So nice and easily, to go from 27 to 17, we'll take away 10 minutes. And boom, that's it. We're done. Seriously, we're done. Because we had 4 hours and then we took away 10 minutes. What's 4 hours minus 10 minutes? 4 hours, take away 10 minutes. Well, that's gonna be 3 hours. And well, 1 hour is 60 minutes. So if you take away 10 minutes, that's 50 minutes. So it's 3 hours and 50 minutes. So it's a pretty fairly quick way to do mental math. But again, we needed to know the connection before we got there. But we are there. We're good. Answer is A. So let's go ahead and move into example number 2. Let's see if we got something else going on, something funky, but we're going to treat it the same way. What do you want? What do you have? What's the connection? Let's go. And here's example number 2. Now, if you notice, we're going into a new unit for the arithmetic reasoning. This is unit 3, unit conversion word problems, just like the previous question. And remember, if you're in my full program, all you have to do is open up your arithmetic reasoning course and you'll have on-demand lessons, guided practice, and over 1,000, 2,000 questions just for this topic where you can practice with step-by-step solutions. So don't forget, that's in your account already. Get in there and practice. And if you want more information on that, if you're not in there, just reach out to me. My information's in the description of this video, descriptions, everything. Just go ahead and catch that. That way you can go ahead and raise your score nice and easy without the stress. But here we go. We have ourselves over here. We see how much should you expect to pay to ship the item right here. How much should you expect to pay to ship the item? So cost of shipping, I'm going to say that right here. Step 1, cost to ship equals blank dollars. Now we're going to immediately go to the information because we want to know, well, what do we have? What are we shipping? How much does it cost? What are the rules? And then we're going to stitch it all together and find out how much it is. So here we go. Let's first erase this right there and let's go. So you'd like to ship an item that weighs 1 pound, 14 ounces. Okay. The post office charges $9 for the first 4 ounces and $4 per ounce thereafter. How much should you expect to pay? So write those pieces of information down immediately. I said, okay, cool. It says $9 for the first ounce, or for the first 4 ounces, excuse me there. So $9 for the first 4 ounces. And then it says over here, I'll highlight this in red, or not red, okay, excuse me, I'll use purple, and $4 per ounce thereafter. Okay, so then $4 per ounce thereafter. So after the first 4 ounces, that's what that means. So we have to be very careful about how we structure this because if you don't do this correctly, you're going to get the wrong answer. So here's what we have here. We have 1 pound and 14 ounces. Let's go ahead and take note of that right here. This is what we have to start with. We have 1 pound and 14 ounces. Now, for the sake of just making sure that we're using the proper unit, let's just go ahead and convert that 1 pound, 14 ounces. Immediately, let's go ahead and convert that just to ounces. Now, why are we converting this just to ounces? Because immediately what I noticed is that, hey, you're paying $9 for the first 4 ounces, $4 per ounce thereafter. So this is all in relation to the number of ounces you have. If you're given pounds and ounces, convert it to ounces first, then deal with this. And this is actually pretty straightforward because my party people, 1 pound equals 16 ounces. I almost said 14. 1 pound equals 16 ounces. So this pound right here, we can just write that as 16 ounces. Then we already have the 14 ounces. So together, this makes 30 ounces. So we have a total of 30 ounces. We need to understand that all we did was convert from pounds to ounces and see the total of ounces we have. Because the first 4 ounces, that's going to be the $9 charge. That's the flat fee for the first 4 ounces. Now what's remaining will get charged $4 per ounce. Now, how many ounces is that we're going to apply the $4 charge per ounce to? Well, take away 4 from 30. That's it. We had the 30 ounces total. The first 4 ounces, that's the $9. So what's left? Well, I think we can do some easy math here. 30 minus 4, that's going to be 26 ounces. Boom. So now that we know, we're good to go. Because here's what we can do. I'm going to structure it like this in terms of being able to visualize it for you nice and easy. We see that the first 4 ounces, that's going to be $9, like we said. We agree on that. Now, the remaining 26 ounces, well, that's going to be $4 per ounce. So it's $4 times the number of ounces, which is 26 ounces. And once you understand that you're splitting the cost between the parts of the ounces that you have, the first 4 is this, the leftover is this, boom, you're good to go. Because now it's just mental math, calculation, and we're good. What's 4 times 26? 4 times 20 is 80. 4 times 6 is 24. 80 plus 24 is 104. So we have $104 right here. We have the $9 right there. add that together, and that's going to give us $113. That is the total cost to ship this item. Booyah. And we're good. So my party people, that's example number 2. We want to make sure, again, that we have all the confidence in the world. So make sure that if it's something that gives you trouble with unit conversions, practice unit conversions. We can do this with more videos on this YouTube channel, or if you want everything organized for you, again, my full program is the way to go. Reach out to me if you want more information about that. But let's go on, get to the next example. Let's keep having fun. Welcome into example 3. So looking at example 3, you can see that the topic here is Unit 2 proportion word problems. And the thing is, this is going to be a problem that gives a lot of people trouble. This is an example that I've been sent a ton of times, and I've recreated it, making sure that I'm not plagiarizing. And I made this specific for practice and making sure that you know how to handle triple ratios. So let's read the problem together so I can show you why this confuses people. But then I'm going to show you the really quick way to do this so that way you're not stuck on it. So here, it says how many red balls are in the container. So immediately, we want to know the number of red balls. So just write that down. We want to know blank red balls. Sounds good. Now, there's no if in that question sentence, so there's not really other information that we are guaranteed to apply yet. But let's read through the problem. Let's see what we got. So we see here that says there are 3 types of balls in a container: red, orange, and yellow. Okay. Then it says the container has a total of 108 balls, and the ratio of red to orange to yellow balls is 1 to 3 to 5. So let's write this information down very carefully. You have to understand how this is all related, because we want to know how many actual red balls are in the container, and we see that there's a total of 108 balls in the container. So let's make sure that we draw the comparison here. We're looking for the number of red balls in the container, and we have 108 total balls in the container. Write that down. That's related information. So blank red balls, 108 total balls. And again, this is in the container. So I'm allowed to piece these pieces of information together. I'm allowed to. So what about that 1 to 3 to 5? What does that mean? Well, let's just write it down right here. So let me just make sure I wrote that down, 108 total. And then over here in purple, I'll say that the ratio of red, orange, and yellow is 1 to 3 to 5. So right there. Cool. So here, again, we have the word ratio listed, which should give it away that this is a proportion problem. But we have, again, red, orange, and again, the order matters, so make sure to write them in the right order. Red, orange, yellow, 1 to 3 to 5. So I am feeling pretty good about this problem, because if I want to set up this proportion to solve, remember that my key piece of advice, aside from compare the same things in the same way, my really big piece of advice is going to be to set the proportion up based off of what you're looking for. So what I'm saying is, hey, we are looking for the number of red balls, and that's been compared to 108 total. So if I want to set up a proportion that I know is going to work, I need to make sure to compare in the ratio, compare the red balls to the total balls. Again, what have I always said? Compare the same things in the same way, right? So that's how we're going to do it. We need to make sure that if we have red and total here, that we have red and total there. That's going to guarantee our success. So my only problem is I see right here that this is red, but I don't see a total. I see orange and yellow. How do I get total? Well, what is a total? A total is everything added up, right? The 108 total balls, that's adding the red, the orange, and the yellow together, correct? Yeah. You can do the same thing in the ratio. You can add up all the parts of the ratio to get the total number of parts. Remember, ratios are just parts of wholes. So here, I can add this in right here, a total, and the total is just going to be everything added up. So that's going to be 1 plus 3 plus 5. 1 plus 3 is 4. 4 plus 5 is 9. So my total is going to be 9. Now I have what I need. I can take the red right there. That's going to be 1. My total is going to be 9. I have the correct pieces. I'll put those in the right place. And so with that said, my party people, we're good to go. That's the trick right there. And if you want to see more of that, again, we have plenty more practice on triple ratios and proportions. Get in there and have fun with it. But we're good. I can move this out of the way. And what I'm going to do is set up my proportion. I'll do R for red. R for red over 108 equals 1 for red over 9. The red over total, red over total. We have it set up appropriately. We can do cross multiplication and division, or you can see that over here, we can do a quick relationship and notice that 9 to 108, that's a multiplication of 12. So 1 to the answer would be the same thing. 1 times 12 is actually a pretty easy deal, and that'll be red equals 12. So we have 12 red marbles. And there you go, or 12 red balls. But there it is, we're good. So again, get that practice in, get that practice in, get that practice in. If you like this part of the video, teaching you a triple ratio real quick, make sure to comment that you discovered something new. I would love to see you succeed. But with that said, let's get on into practice problem example number 4. Let's go. All right, now let's get into an example here that can definitely trick a lot of people if you're not really careful about knowing what the question's asking. So right in the beginning, we always want to start off with the question, what do we want? So right here, how long was the foam tube before being cut? Okay, now there's a key word in here that if you don't pay attention to, again, it's gonna make a big difference. So here's what we want. We want how long was the foam tube. So basically, foam tube was blank, but here's the big part. They give you a key piece of information before being cut. So this is a huge, and I mean huge piece of information because it's going to lead the way for us in terms of what operation we're going to be doing. So when you cut something, just think about it. When you're cutting something, typically what you're doing is you're either subtracting or dividing. But in the problem here, you're going to notice that this is dividing because look, a foam tube was cut into 6 equal pieces, each measuring 5 inches in length. Cut into 6 equal pieces. It was cut into 6 equal pieces. So that means it was divided because when you cut into equal pieces, that's division, or when you group things out. So with that said, the foam tube was blank before the cut, before it was divided. So if we want to get back to the original length, we have to do the opposite of dividing it into equal pieces. What's the opposite of dividing? Multiplying. And that's going to be a big hint in terms of how we solve this problem. So again, before the cut, before the division, so to get the answer, what we're going to do is we're going to work backwards and multiply. So the information that we'll use is right here. A foam tube was cut into 6 equal pieces, each measuring 5 inches. So 5 inches each piece, and you have 6 pieces, you'll multiply right there. So here's what we'll do. 5 inches each piece, or per piece, either way you want to say it. And then we have 6 pieces. So we'll multiply this by 6 pieces, and voila, we have 30 total inches. Now you may think that that's all you have to do, but you're wrong because you look at the answer choices and it looks like we've converted between just inches into feet and inches. Now this is a very quick solution. If you know and practice this enough, well then you know automatically that's going to be 2 feet and 6 inches. But if you didn't know your mental math quickly, here's a nice way to translate and convert. So what we know is that 1 foot equals 12 inches. So to convert from a small unit inches into a bigger unit feet, what you would do is you would divide because you're grouping up all of the groups of 12 inches that you can to make them 1 foot each. So 12 goes into 30 how many times? Or basically how many groups of 1 foot can we make? Well, 12 goes into 30 twice, so that's 2 whole feet. When you subtract, 12 times 2 is 24, you'll get a leftover of 6. And this is what's remaining.
That's the remainder. That's 6. 6 remaining inches. And there's your answer. Super fast. 2 feet and 6 inches. There we go. And we're done. Super quick, super straightforward, and we can say that confidently that the answer is A. Boom. So with that said, we've got one more problem to go, but have you been noticing that these strategies have been remaining the same? Make sure that you're asking yourself, what is it that I want? What information do I have? And then what's the connection? If you follow those 3 steps, you'll be able to tell, hey, what mistakes am I making? Where am I getting stuck at? How can I move forward? So let's practice this one more time with example number 5. All right, example number 5. And with this one, we're looking at another unit here. We're looking at percent word problems. So boom, right there, that's the name of the unit, unit 4. And I'm gonna make sure to highlight that for you because again, if you're in my full program for the ASVAB, just make sure to log into your account, open up the Arithmetic Reasoning Bootcamp course, and you'll have unlimited practice for this with step-by-step solutions, guided videos, on-demand recordings, like literally everything you need. So I'm gonna just say that once again. And again, if you wanna learn more about that, just reach out to me. Go to duranlearning.com, go to the link right there, find my number in the description of this video. Just reach out to me to make sure that you're good to go. I got you. So here we go. First things first, read the question. How much money will George save on the groceries? Now, I haven't read the whole problem yet. Like these are problems that I pulled from my question bank and I haven't solved them yet. So I can guarantee you that from your perspective, this is doable. Read the question first. I have no idea what the problem's about, but I do know that we're talking about saving on groceries and we're talking about money. So we want to know how much George saves, so we can phrase that like that. George saves this much money. Okay, great. Now let's go ahead and gather the given information and let's find the optimal path. Let's find the best path forward. So here we go. Right on, George sees that the $146 in groceries he wants to buy will have a 40% discount applied at checkout, bringing the total he'll pay to $87.40. How much money did he save? Now, there are 2 ways to solve this problem. One is going to be the very, very, very easy way that doesn't even involve a percent. And the second way is going to be using a percent to get the same exact answer. So I'm going to show you the setup as a percent, but then I'm going to point something out that's going to make this super easy. So remember this about percents. So again, I'm going to solve this in 2 different ways, but again, the second way is going to blow your mind because you just have to pay attention. So here, remember that the percent you apply represents the amount you get. What does that mean? Well, look, if I want to know how much money George is saving, so whatever the result is of this percent that I'm going to set up, if I want to know that the result is the money saved, then you need to use the savings percent. Right there. So let me just state that for you here. Again, the percent you apply represents the amount that you get. So if you're going to be applying, and this is terrible handwriting because I'm writing so fast, but if you're going to be applying the percent of the original equals the result formula, well, the percent you apply, the discount percent that you apply, that's going to translate to the discount amount. If you apply a tax percent to an amount, then that'll be the amount of the tax that you receive. If you subtract the discount from 100 to show the percent of the final cost, well then that'll give you the amount of the final cost. So these are some big tips that I'm giving you here. Write that down, rewind this, write it down again, because it's very important to make your life very easy. So to get this problem done, again, super easy. The savings percent that we noticed in the problem, 40% discount. So I'll apply 40% of the original cost of the groceries, $146, and that's going to equal the amount that we saved. So we're good. And so to set this up, 0.4 times 146 and you'll do your thing and you'll solve this. But pay attention here, don't skip forward, because I'm going to show you the really easy way to get this done as well once we're through with this. So 6 times 4, that's going to be 24. 4 times 4 is 16, carry the 2 is 8. 1 times 4 is 4, carry the 1 is 5. And then we see that we included one decimal place. So that's going to be $58.40 in terms of the amount that you saved, because that was the savings percent. And so therefore, C is the correct answer. But wait, let me show you the really, really easy way to do this one. Because if you notice, the problem told you, well, okay, guess what? Here's the original amount. Here is the amount that you paid. So to find the discount, subtract. If this is what you were supposed to pay, but this is what you actually paid, the discount is the gap, right? So if you wanted to, you could have just done this too. If you wanted to, you could have done $146 minus $87.60. You could have done it like that. Now, instead of doing it, straight up and borrowing ones and all that jazz, you can simply go ahead and just subtract one place value at a time. What I mean is, if I take 146 and subtract 80, well, 14 minus 8, that's going to be 6. So that's 66 minus 760. 66 minus 7, that's going to be 59 minus 60 cents. And then lastly, take away 60 cents, that's $58.40. You can do that in your head mentally super fast. And I just showed you how to do it. So either way, you'll get the same answer. But notice that this problem allowed you 2 different opportunities to get it done the right way. And that can happen with different problems. You can have information that might be extraneous or extra information that you don't really need to use. But either way, I truly hope that this helped you, my party people. Like this is really, really, really fun. I enjoy teaching. So again, if you need any extra help with the ASVAB, feel free to go to duranlearning.com or reach out to me. My phone number is 567-698-8867. But with that said, let's go ahead and end this video off on a good note. Let's recap, give you some more tips and strategies, and then I'll see you for part 3 coming up sometime soon. And that's it for today's video, my party people. I hope you found it helpful and learned some new strategies for tackling ASVAB arithmetic reasoning questions. But here's the thing. I'd love to hear from you. What was your favorite part of the video? Let me know in the comments, and don't forget to like the video if you found it useful. And as always, don't forget to check out the link in the description for a full free ASVAB practice test with video solutions and that free registration to my weekly classes on Zoom. These materials can really help you succeed on the ASVAB, so don't miss out. So with that said, thanks for watching, and I'll see you in the next video for part 3, coming up with another 5 practice test questions and walkthroughs. As always, my party people, I love y'all. Let's keep raising our scores. I'm Coach Anderson, and I'll see you in the next one.